Okay. Testing, 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 testing. Everything looks smooth. I don't know what's going on with my camera, but I look like Gleep Glorp. Yeah. Yeah. I look like, I don't know. I look like an alien, I guess. Um, and I'm keeping up with my stream quality here on another iPad. It doesn't look very good. So that's a shame. And I thought it was looking pretty good. So I'm wondering what I can do to fix that. Also, this live chat is not looking good. Let's see here. We're still in the process of setting up. No, not that one. Let's see here. Bum, bum, bum. Okay. Let's see. We're looking for live. This one. Streamception. Pop out chat. Copy the link. Like, there has to be a faster way to do this, right? There we go. There's the chat. Okay. I mean, it's not great quality. I'm seeing what you guys are seeing over here on a little iPad, and I see that it kind of sucks. What's up? Welcome, guys. Welcome, welcome. Yeah, I hope it's not too bad. The quality. I don't know. Should I care or should I not care? I'm wiggling this here, and then a couple seconds later. Whoa, way more than a couple seconds later. But it doesn't matter if there's a delay. Actually, it doesn't look too bad. I feel like the CAD is okay. But me moving maybe. There's definitely a delay, but that's not a problem. It's more about the lag, right? Let's see here. I'm still experimenting with this stream stuff. It doesn't look too bad. I feel like I've got a bitrate right now of 1317. Which is pretty bad. But like it's manageable. Maybe. Let's just go. And if you guys complain, then maybe we'll do something about it. But if it's not too bad, we'll just roll with it. Okay. Hey everybody. Welcome. Good to see all of you here. Hello from France. Thanks, Ghost 9 Rival 1. Very awesome. I love France. This CAD model is I'm working on a new like 3D printer enclosure. That's what's printing in the other room right now. If we go here, you can see my printer printing all these parts here for this enclosure. And I'm not working on this today. Instead, I've got to do some updates on the, on the web. That is what is important for today. Yeah, I know. That's what I'm saying. I look like Gleep Glorp, like an alien, you know? Um, I think it's pretty funny. So I was working on the web, and basically I was trying to do like do as much as I can with like the old hardware, like especially the old hardware I can't change, like the pressure vessel. Obviously, the circuit board is newly updated, so that's going to stay because that's a very good, nice, compact circuit board for this project. So we're going to build around that. But I still have an old pressure vessel that I really think can be improved. And then I've done some notes here. Let's see, where did I do this? Did I skip a bunch of pages? Looks like I skipped a bunch of pages in my notebook. That's not fun. Okay, reinforcement learning. Reinforcement learning. Reinforcement learning. Okay. Yeah, new pressure vessel is sort of the idea. So I've got some scribblings here, and I've decided a couple things about the pressure vessel, a couple of things about the latching mechanism, a couple of things about stowing the mechanism so they're not visible, the motors so they're not visible, changing the shape of it a little bit to make more efficient fluid storage, just trying to make things make more sense in the design. And I think that is going to help me greatly. But yeah, it means that things are going to change somewhat. So this design, where we're starting with today, you guys haven't seen this yet, but that's coming in a video. Is it like pretty much as far as we could have got, as far as we could get. I'm really going to try today, and hopefully will only take today, to like straight up make a design that has me thought of everything. Like instead of just trying to like go an extra mile every time I update this design, I want to go like 200 miles at once, if that makes sense. Yeah, so I'm going to make a copy of this here. One of the first things I want to do is actually like define the shape and try to hold myself to that shape, and not have it be like, uh, you know, poking, like little things poking out of that shape. You know, I want to be smooth and sleek and a little bit nicer, I suppose. So I'm going to call this Web 3. Web 3! Just like the crypto bros say. That's funny. All right. And there's a couple things that we have to check out. And I feel like we got some like intermediate steps to do because the latching mechanism needs some work, the mechanism needs some work. The pressure vessel needs some work, and the pressure vessel we won't be able to like make soon, but we will be able to get PCBWay to make it, which will be very good. And this is the current pressure vessel. And like since I've made this, I think this is a design that came about over a year ago now, which is crazy. So it's like way overdue for an update. And every time I look at this, I'm like, why did I do this? Why did I do this? Why did I do this? And there's something to be said about I made this as simple as possible so that I could actually build it myself. Like if I had to, you know, on my CNC. But then it's like we have PCBWay services at our disposal. Let's like have some fun with it, you know? Like don't make the easiest to manufacture pressure vessel you can make. Obviously, you still have to adhere to the constraints of like machining, but I think that we can get a little bit more creative with this. All right, let's see what we can do here. Let me look at my sketches. So the first things first. So I have one step. The first step is design the adjustable bracelet. And that I think goes along with what I just said, which is like the shape, the overall shape of the thing. So this is going to be tricky. But I also know that I pretty much have the minimum like volar altitude of this bracelet, which comes from this pressure vessel. So what I'm going to do, first thing I'm going to do is move these parts here. I think that's everything. We're going to move them back to their original position or thereabouts. I think yeah, I think we can do it if we just do point to point from here. No, that's not going to work. We should just move it manually and try to fit it right. Okay, translate along. Free move, set pivot. Bodies, we need to select all of these. There we go. Okay, let's try to match this up here. So this is the adjustment of this mechanism. It doesn't look like we've quite got it yet. What the heck? Did something go wrong? Did I accidentally move something I shouldn't have? Yeah, great question, Shira. That's one of the main things with Web3 is I'm like, this has gotta be more covered up. I don't like having the linkages exposed. It feels very vulnerable. I don't like that. Okay, something else is wrong. This whole thing is like incorrect. Okay. Let's see here. Good. So that's like the maximum. I'm going to start simple, make a plane, offset it 10 millimeters. And then we got to make the shape of this thing. Okay, so we've got this surface here. And got this circle here. Those are offset. But what happens if this is why you pay attention in your geometry class, folks. This constraint, and then another circle that's the same size as this one. Right, okay. And then if this circle is the same size as this one, it's pretty much concurrent, which is what we want. So that's how I imagine like the shape of the wrist. It's like a slot, like a big slot. A lot of people think of it like an ellipse. I did some tests, and I think that the slot shape is more comfortable. So let me show you what I mean. It's like the difference between like this shape I want to like get rid of stuff. It doesn't matter. Okay. It's like the difference between I guess we can see it over here. You know what? I'm moving this further. Okay. So I'm thinking about like the difference between this shape and what maybe I would have done without thinking, which is like this shape, you know? So the ellipse. Some difference here. You get a little more room. La 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 la. And the thing is, I found this shape by measuring like the width and height of my wrist. And like a more accurate one is not really relevant. It's more so like, if you have little bony parts poking out here, it's going to be much more comfortable to have that extra room. So that's why I settled on this shape instead of the ellipse, and it's worked quite well. I actually think that that is one of the little victories that I came across that I didn't really register. So that is our inner shape here. And then we have a couple things to look at. Is that concurrent or not concurrent? Let's see. Okay, they have slightly different center points, but pretty close. So if we look at like this circle versus this circle, that gives us an idea of what kind of thickness we can get, like the minimum thickness, which I believe is about 12 millimeters. These up. Okay, gotta have them have the same center point, even if they're a little bit off. If we dimension between these two, 12.59. I think I'll just call it 12.6. So then what we do, besides making all of this construction, we offset this slot by 12.6. Okay. So then the idea is just to extrude this shape and like feasibly to cover all these things up, we're going to have like from here to here, which I don't even know what that is, honestly. I'm going to extrude this first and then look. Okay. Now I want to take a look at how much space all our little extra pokey stuff had to take up. So basically from like here to here would be a reasonable depth. So 58 millimeters. Okay, great. No time for decisions. 58 millimeters. Okay. So this is going to look much better. Like I want to stick to this kind of shape. Yes, that's what I think. We've got to try to fit everything inside here. It's not going to be like totally doable though, because this motor is like 16 millimeters. So maybe if I'm thinking realistically, that motor is not going to be able to be lifted much. So if I look at the front of this and I project the shape of this motor onto it, we can see that it's a little bit impossible to fit that in. Now, that's on the back side of the web, which is not as like offensive from a design standpoint, I think, if there's bumpy stuff there. But I still don't want it to be bumpy. What I'm going to do, just so I can keep thinking about this problem realistically, is first get the mirror line here and mirror that over this way. Then all this stuff should just be construction lines. Then I get a rectangle here that should be pretty like total for like that's encompassing like motor and relevant stuff. And then if I offset that by 0.8, then I should get a reasonable like wall distance. So if I'm thinking about like this flat part is going to be like the bony part of my wrist. So what I'm going to do is I'm going to extrude this through this shape. So that's a more realistic profile. It kind of looks like a watch, so you have this like flat part here. I'm gonna add some fillets or chamfers. Fillets or chamfers. Fillets here. Always can't decide on a radius. I think that, just shy of touching the edge. And then add a chamfer here. It's just a slight one, I guess. It seems like that could get annoying. Reduce this chamfer to 7, or this fillet to 7. And this chamfer gonna be 1. Okay. And some chamfers on the inside as well, or some fillets on the inside as well, rather, because this could get like pretty hairy pretty fast. Oop, nope. 2, 3, 10. 10. Okay, so if I had to guess, like if I put this on, it would be pretty comfortable. I don't know for sure, but I think one of the things that I want to do, you know, before anything else, well, I'll do some other things because my printer's still working. It's got 4 hours left, so I'm gonna keep working like under the assumption that this, what's going on here? I'm gonna keep working under the assumption that this is gonna be like good, because I've made shapes like this before, and they are quite comfortable. But I don't know. I don't know, you know, if this specifically is going to have that same effect. I mean, the other thing we can think of. I'm going to leave it here for now. I don't want to overcomplicate it. Like this could be comfortable. We'll keep it here. I can modify it later if it's uncomfortable. So, okay. So design adjustable bracelet. That's my first task. I set that for myself a couple days ago. I'm gonna stick to it because I'm a smart guy. And then something else, something, and then I don't know. I don't know. Why Fusion 360? Because it's one I'm very good at. I am also a certified SolidWorks associate as of the year 2019. In the middle of college, I was like, I'll take the SolidWorks associate test or whatever. So I have that certification somewhere, but I haven't used SolidWorks since probably a couple of years ago. So the adjustability part is the key. And I do know that it's going to have to slide along a certain plane. And I think the angle of the plane that I have is quite good. So I'm just going to draw that plane at angle. Maybe Where's the break right now? It's up there? Okay. I'll draw that here. And then to object. Okay. Okay, I'm going to copy this body. So I'm going to call this body base bracelet. And then we're going to copy that and move on to, let's call it sliding bracelet. We'll do this in steps so that I don't lose anything. And I know that like technically that's what this is supposed to do, but I want to have all the steps at any point in the timeline, if that makes sense. So the idea at least was how am I going to fit all this stuff in here? Let's think. Okay, there's some other things to think about too. Namely the trigger slot. Okay, I gotta go back to the base bracelet. So if you look on the back side here, there is going to be this inlet. Poof. We are approaching dangerous levels of cope. 10. Okay, so we need to account for like a 10 millimeter hole. This is the inlet. Hey, 610 is here. What's up, 610? Welcome. Okay, so this is still very much possible to fit this in here. What I want to do, we need something that's tangent to both, so I can center this properly. Right, okay. And then what we need to do, draw a hexagon. That has the same side length. And is perpendicular to a line that is perpendicular to the tangent. There. You guys see what I'm doing here? So we can place this inlet wherever we want. Right now we have it over there. Question is, do we really have space for it? I mean, I think we certainly have space for it. I'm gonna stop popping my jaw. It's really annoying. Let's see here. Yeah, I mean, the thing is, it sticks out a little bit, but that's not really a concern. It's just like, a fraction of a millimeter. So it's actually kind of perfect size. The other thing is, it's still going to fit within the length profile. It's going to be kind of embedded. It's not going to stick out like in the current version. Yeah. It's a lot of I'm spending way too much time on this. It's more so like the fact that this thing is going to have to split apart. I'll just keep that sketch there for now. I think it's clear to me that this is going to fit. The other thing that I have to keep an eye on is the motor. And this might, so it really just, I was trying to see if I needed to change the shape of the profile at all, but it doesn't look like I do on account of the inlet. So that's good. The other thing is there's another motor to activate the trigger retraction, and that one is smaller than the other motor, so that's good. Do I have it here? I really should have it. What did I do? Okay, well, it's pretty clear to me that I can reconstruct the profile based on what I have done before. What the hell? I think it's not a big deal if it touches the wrist, actually. I don't think it will affect the comfort that much, but I guess we'll see. Oh, shit. I screwed up. So it's really simple. One circle, one rectangle, new body. And then this one is just more rectangle. With this one being tangent to the circle, and this one being coincident with that point. Buddy. And then that just stretches past here. That's the gearbox, basically. Okay, it's probably a safe bet. It's probably an overestimation of the size. New body. Then we combine those two together. Then we can get the shaft. From this circle. I gotta go turn my AC. BRB. Okay. 3. With a line. And that line is, what is that? 3 minus, no, okay. 1.5 minus okay, I'm looking at like 2.6. So 1.5 minus wait. What am I thinking? Okay. Jesus Christ. 3 millimeters in diameter, 1.5 millimeter radius, and then I want to subtract 2.6. Okay, so it's going to be 1.5 minus 3 minus 2.6. There we go. Okay, and then that goes, you know, I think probably there, right? Okay. New body. Okay, let's get rid of these here. Great. That's our motor. Combine these two. We need to rotate this about an angle that we measure. Bing bong, get it back to being level. Okay. Then I'm wondering. Right, okay, so we want to see how we can fit this in here. I'm going to do point to point to here. And then we can move it around. Because the idea is that we're going to have some extra gearing. Because I know for a fact, because I've tried it, that this, yes, this is the N20, which was suggested by a commenter, the right angle version. And at first I thought I could just drive the trigger directly from that, but it still doesn't have enough torque, which is so stupid. And you know what? It also doesn't have enough speed. But that's not really like the worst thing in the world right now. I'll just keep it for now. And I'm sure there's like maybe a faster version once I get the gearing down. But let's see here. So we're gonna need some extra gearing, which is gonna be even slower. So that's why this gap between this motor and the back exists. So we don't want to adjust that. We want to adjust the height so that it stops poking out. Okay. So it's definitely going to poke a little bit, but what if we play some tricks? Oh! Okay. That's quite something there. Okay, that this can still fit if it's tilted. And then even if it's tilted, we can have, that's a pretty easy gearing to fix. Especially because we're going to have a few stages. So that's pretty exciting. I think I can think it definitely has to be separated. What I want to do is get this in a sketch form so I can move it around in the way that it should be moved around. That's good to know. But if I can get away with the cheaper motors, I will. I'm quite certain that I'm not using the best motors out there. I've been to robotics motor actuator companies at exhibition floors, and it's just not worth the cost. Like the difference between these cheap, shitty Chinese motors and the high-end ones, at least as far as I've seen, I'm just like, meh, Okay, I'll put that there, and then got to check out the motor shaft as well. Okay. And we take all this, make a construction, then we take all this and copy and paste it. Maybe we have to select everything individually. That would be fun, right? Let's draw our constraints here. Over-constrained, got it. Nope. Okay, now this all moves together. So then we offset this by 0.8 to make sure that we have some buffer, you know, before the human skin, and maybe even like 0.5 will be fine. Let's try that. And I'm kind of like, yeah, I mean, that's definitely the way to go. I need to make the midpoint of this coincide in here. And voila. Now this is nice and transformable in the way that we want. So over here is sort of how we have it there. And that certainly works. I mean, even like putting it here. Yeah, what is really, how did I sketch this out? So the interesting thing here is that this is behind the part of the bracelet that has the nozzle, right? So if this is behind the part of the bracelet that has the nozzle, because we want that to be smaller, and so this is going to be, you know, activatable like this. This is not going to be activatable like this, unfortunately, but it just makes more sense from a physics standpoint to do this. Believe it or not. And so, oh, what just happened? Okay. And this is behind the nozzle, which means there's not really much point to have anything. So it could straight up just be, because there's a lot of room here. I don't know. Nozzle's going to be in the center here. How much? Do I still have the nozzle in here? I don't know if I do. I bet it's in this version though. That's good to know. Thanks, Shira. Nozzle, 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 nozzle. There it is. So the nozzle design is going to be relatively the same. So this is what it looks like inside this pressure vessel here. So essentially like 7 millimeters, call it 8 millimeters to be safe. If that's the case, and this is going to be presumably right in the center. Got an 8 millimeter nozzle. Yeah, I mean, that can totally just fit right there, can't it? The shaft will be behind. Yeah. That will just be straight up right next to the nozzle. The other thing to consider, no, then we certainly have enough space. There's certainly enough space. So we can make that level, which is good because it saves some space. Saves a lot of space, actually. Okay, great. So I'm going to call it horizontal. Boom. So there's just going to be this little bit out here, which, as you can imagine, is not a lot. What I'm going to do is mirror that over. I suppose we do need to like offset that by like 0.8 to be safe. Okay. So that's going to be your nozzle side, your underside of your wrist there. Does need to poke out a little bit, but not an insane amount. I'll worry about the motor, like the actual motor body later. I know where it's going to go. I'll do the same sort of design here. I won't try to hide the bump. I'll just give it a fillet and a chamfer. But a smaller one, admittedly. Something like that. I'm looking at your comment here. 150-gram combat robots. That's fascinating. What did you say? Ant weight combat robot. 150 gram. I guess, okay, that's why they call it ant weight. Interesting. Let's see what this guy has on Reddit here. Oh, wow. Small, huh? Very small. 150 grams. So you do combat robots then? I did this in high school. That's all we had. And then I grew up with the more bougie school district people in college being like, "Oh, did you have first robotics? Did you have first robotics?" Bunch of nerds, you know. Not that I wasn't, but we just had BattleBots, and that was, you know, not a lot of actual robotics, more so just extreme engineering. Let me see if there's a video. I hope this is audible here. No, I think I need to set up the... Let's see. Sound? There we go. You guys can hear this now.
Oh! Revolve is where things got started.
Okay, let's see. So are these ant weight? I can't tell how big this is. I kind of get it though. Like things spinning really fast can be really light and still be like dangerous.
Oh! Revolve is where things got started. It was my first combat robot as well as the subject of the first video
small.
on this channel. It's a 150-gram ring spinner type machine that is definitely the project I'm most proud of. The heavy ring spins around a fragile central robot. It is only one trick, but it's a pretty good trick.
That makes sense. You get like a really strong, like ring, and then the robot inside could just be like paperweight, you know.
The final version recorded in the first video featured a successful implementation of a hub-motor drive for the web.
What did this man do? Just like walk right in. Look at this. What is happening? It's like the worst, the easiest opponent. We would always be on the team that got clobbered though. Just, yeah. Cleveland Heights High School. It's like the other team isn't even trying. All right. Anyway, that's fascinating. Wow. Okay. Oof. Where were we? Okay. Hope Fusion doesn't crash. There we go. Save now. Okay. So we made space for that. Smooth valve. Yeah, okay. So pretty decent shape. I think, is there anything else? Oh yeah, the trigger. The actual trigger needs to slide underneath everything that you can see here. And so the trigger has conductive material on it, obviously. And the problem is that it's like running against aluminum pressure vessel. So I had this problem when I first built it, that like I had to put some tape on the aluminum essentially to stop that from happening. And tape is nice, it's really thin, but it would be much better to have like a dedicated track for it, you know? So I want to try to build that in. I'm wondering if I can just stick it right there. I'm pretty sure that I can. So if I give this an offset of, well, to look at my sketch, because maybe I shot myself in the foot by putting that motor there. God, there's way too many sketches here. I need to like export a step and start over. Yeah. So if I get a nice thin semi-thin area for the trigger. The opening hinge directly to the pressure vessel. Yeah, not a bad idea, actually. I think I might do that. That, of course, will be a later step, but that's also what I was thinking as well. The problem is I put this motor here. And now I'm like, well, I kind of want to have the trigger here. But then the trigger could be thinner. Ah, shoot. What have I done? What have I done? I can make it below everything. But would that be kind of a cop-out? Might be. I think yes. I think I have to reposition this motor. Hey, been wanting to comment or message. Been working on a potential Spidey mask that's thin enough to have zero face shell, but with reactive eyes. That's very interesting because I've only seen masks that have face shell and reactive eyes. That's pretty cool. I mean, I probably am not immediately personally interested, but I'm interested like to hear how it goes for you, you know? So if this is the space that I want for the trigger, which it doesn't necessarily need to be that space. How wide do I have it right now is probably enough. I just need to be, the trigger has been probably the worst thing about this. The fact that I'm trying to add this on to a design that originally did not anticipate it. Look how offset this is. Okay, 16 millimeters. That's 8. So if that's the trigger slot, if that's the trigger slot, then we got to move this motor a little bit. But what I can do, before I go through my 500 sketches, let's see the N20 here. I'm going to move it from this point to this point, and then I'm going to rotate it around that, measure between this and this, negative that, of course. Okay. And now from here, I can move it again according to this circle. So just to get it out of the way of the trigger, just like that. And this actually is like kind of okay. It just means that I can update this. I think that a tangent line might do it. Just barely. Barely doesn't make it. What happened to my camera? I have no clue. I don't know. It's not my camera. It's I at first I thought it would be okay because it looks like it's just a computer like graphics problem because like I try to adjust the feed on my like camera software. Um like I was trying to adjust the hue and like maybe I can make it look more normal or whatever because it's so green. I can like detint it or something. Um but it just like it's clear that this is after the camera, so that didn't work. If I project this here, should be enough. Okay, so I'm thinking 3-point arc, but it kind of gives some pizzazz to the stream. You know, I'm like the Gleep Glorp alien, whatever. Going through your old comics from the 70s, replicate the gadgets. Yeah, and those comedies from the comics, those comics from the 70s are like, they're some of the best, you know. Okay, gonna try here. Is gonna be tangent to here. See how that looks. I mean, that's not bad. That's not bad at all. Let's add a little more material. We're just sacrificing our principle of of sticking to the shape little by little until, of course, inevitably it gets way too bulky, as is the history. But so far, we're looking better than we did, right? So that's good. It doesn't have to be symmetrical, of course, but I think it helps it look like this extra space is intentional. Okay. Okay. Crazy stuff, but it works. Okay, so here, finally, I believe we have, this can always be adjusted later. Yeah, I'll just go with this. The camera's intentional. Totally intentional. Of course. This is our profile, because this is going to fit just fine. We've accommodated space for the other motor and for the trigger. And then the length is less of an issue, of course. So bracelet. And this kind of sucks. There are some parts of this that are like more bulky, but not really, because the motor is there. So I don't know. This is what it's going to take, I think, to fit everything in a sleek way. Gosh. How much left is on my print? 3.5 hours. Okay. All right, now finally, let's move the history marker forward. And we've got our plane, and we've got our copy. Nice. Okay, so we're back to where we were about 30 minutes ago. Before I forgot that I still needed to do a bunch of stuff before moving on. Okay, and I finished my coffee and my water. Well, not quite. So I think nature calls real quick, and then I'm gonna get some more water. You gotta stay hydrated. Very important, because I have not been doing that. I should probably have some food too. But I don't know exactly what to eat. Okay, first use the restroom. I'll be right back. Yeah. If you guys wondering, 610 is talking about. He said another con of the yellow, which is a funny way to put it. But yeah, no coffee, no booze, no slushies at the barcade, energy drinks, never. Yeah, that's a tough life. But I mean, maybe your body's better off not with those things. Okay. There's a couple things going on here. First of all, we know that like on some level this is going to need to oh, if we split this apart, we know that like we know that on some level that this is going to have to exit so that a wrist can slide nicely in there and then re-enter. Okay, so let's make a sketch and figure out the ways that that might look. Eight pull-ups? 8 pull-ups is huge. That's huge. I'm very pleased to hear that. And then how long did it take you to get 8 pull-ups? Like if that took you like not that long, that's pretty awesome. Because I feel like you just only recently started working on those, right? I don't know why I put this circle here. Let's think about this. Before I had like a hinge, um, I think the hinge is probably the right way to go. I have a lot of thoughts about the hinge and the latching, by the way, that will come up in a few steps. But this has got to be like That's my hinge from before. So but what if it hinged like the other way? You know? So let's see here. If I select these things, maybe I can't. I have to select them one by one. Okay. Let's just do it like that. Okay, what I can do, I can have a point, one here, one here. And I can select these, and I can do a circular pattern. And I'll try selecting this center point first. Do partial. So I can just see how it might move, you know? Looks like reasonably like 85 degrees range of motion is necessary for like a comfortable whatever. And then if I move this around, oh yeah, look at that. So I can move the point of rotation. That's quite nice. Okay. I'm also like, we don't really have room for a hinge up here because that's where the motor is. So I'm not even going to bother. I think the hinge is in the right place. I'm pretty sure. Okay, so it was before here. Wow, that's kind of crazy. That seems pretty nuts. Like, what if it was like here? And then there's the idea of like we can fit more in the farther it is down. So honestly, having the hinge like really close here. And like what reasonably kind of axis can I get? Because I really only need like let's say 3 millimeters, and then to be safe, like 2, right? So feasibly, if I make that tangent here, it's the lowest. I mean, let's see. Why wouldn't this work? So it could encroach on the circuit board's territory, right? But I have a lot more space now for the circuit board to move down for reasons that I will explain. But I'm also, okay, I should reveal my secret now. That before, let's see, before I had latching for adjustability here, and then latching for like the bracelet here. And the latching for the bracelet sucks. Always, like no matter what. So my plan is to put the latching in the hinge instead. We're not going to have anything here. It's just going to be latching in the hinge. So it's going to go, down as it tightens, and then there'll be a release button or whatever. That saves a lot of space here. Allows me to move this all the way down. But then if the latching is in the hinge, do I have enough space for the latching in the hinge here? And it could still have those mechanisms up here, but I don't trust it. So I'm going to say that this should be like, let's say 5 millimeters instead. Okay. So not as nice, but maybe a little bit safer in terms of what kinds of mechanisms that we're going to be able to fit. Okay, I'm going to put that here. Okay, so there's our hinge. The other thing is this door now has these like really sharp edges that we don't really need anymore. So I'm going to chop them, but in an intelligent way. Because remember, this is going to be adjustable, so it needs to be comfortable for a bunch of different arms, basically. And if we take this and rotate it like this, we can see what kind of thing we're creating here. Okay, so what's cool about this mechanism is that already you can see that that is its limit on that side. Over here, obviously, we need to cut some material away somehow, but it's easy. So this already maxes out there. And that might need to be fixed somewhat with the adjustability. And in fact, it almost certainly will need to be. So I should probably construct a plane here. So quite possibly, in terms of like how much this can squeeze, do want to make sure I'm not encroaching on the motor. We're kind of encroaching on the... it's okay. Oh, you can also see here that we've now cut into the motor's space. I was worried about that. It's always a problem here. Why must there always be a problem? Okay, well, I think that if I chop this one here, and I chop this one here, and you know what? I'm going to chop this one here too. Going to combine these, then fix this situation. Because it's okay to have a little bit extra. As long as it's nice and round. I don't know if I like this. Oh. That was random. Okay, wait, what am I doing? What is with this insane shape that I've created? I need to get back to the root. Stop being crazy. Yeah. Just try to keep it comfortable. Add a small fillet. No. We're not getting in the weeds. Details later, details later. Okay. If I get these being parallel, okay, I'm cutting away material here because there needs to be space for this to shrink. It's adjustable. And then after doing this, what I want to do, get the same shape on the other side. Henry is cool, wants me to make more KiCad tutorials. There will certainly be more. Absolutely. There's so many circuits that I want to make. You have no idea. And just the fact that like making custom PCBs has entered my like engineering vocabulary has done me so much good. There will certainly be more. And there's all sorts of, so I'm even working on some projects with a client who, like, he has such great ideas, and what the heck? What am I missing? Why is that? Yeah, no shit, that's the mirror. Okay, what do I really want here? What I really want here is this tangent line versus that tangent line, I guess. And these will intersect here. Sorry, I'm just doing random geometry shit. Collinear. Collinear. Equal, equal. Okay, that's the line fully defined. And what happens when I do this? Okay, not quite. Not quite what I was hoping for. Okay, let's get rid of all this shit. Maybe this doesn't have a geometric solution. But I really want to get the same curves over here that I have over there. Nope. Nope. I know it's going to be mirrored, so maybe I'll just get it close. I have this, but I won't have that be perpendicular. And then I'll have to mirror this along this line. Good. And then I'm going to shift this line until it's in position. Doesn't even look like the midpoint constraint is doing us any good here. You can do it coincident though, because it doesn't really matter. Should lock that in place. I'll have to lock it and then like periodically unlock it and stuff. Oof. By the way, the super chat goal for today, level 1. There could be more, but level 1. And when I say level 1, that means it gets more intense. Okay? So, 60 push-ups is level 1, which is a bit of a challenge for me, but I'm going to do it anyway. Legally, I am marketing the web for all sorts of things. Ooh, wait, I know what to do. I know what to do. Just have this be here and have this be here. There. That's kind of what I wanted. I feel like this will be like a nice, comfortable feel, no pinching. Yeah. So this way, the adjustableness, if I have this right, is going to be like that. So that's for teeny tiny. Rest, we probably don't have to go down that far. And that's for big boys. Okay. 3mm neoprene foam gasket. That's pretty impressive. Low list, low short component list for those lenses you're talking about. So you don't want pinching here either. So add a fillet there. And I'm straight up going to just have this be like 10 meters here. That should be good enough. Well, well, Yeah, I think I should have this be parallel, tangent and parallel. Change to the circle, parallel to this other line. I feel like I'm freaking taking too many shortcuts here. Okay, I can see that. Then we're gonna need all of our wires to pass through this whole thing, which is crazy. But I'm definitely better at that than I used to be. A lot of this stuff is just practice, which is the crazy part. And then sometimes it's better to start from scratch instead of a design that you started like with less knowledge than you currently have. I think there's definitely something to be said for that. You should be combined still. Okay. I'm feeling optimistic now. Got a good start here, like a really good start. The real question is like, I think that probably a good way to do this would be to cut this body here and not have anything go past there. What's up, AZ3D? How's it going? I'm doing well. I was just saying, I feel optimistic about this process here. I'm trying to get rid of this body. I can't select it. This one. Okay, so we've got I'm trying to make like the most intelligent and like forward-thinking decisions that I can here and not have anything jump out at me later. So we also know that this only needs to rotate this much. If we plot a plane here, does this work? I should have moved it. Should have moved it instead. Um, Select this point here. Okay. I gotta draw the line first. Right now I'm trying to find the maximum like rotation of this thing. You know, looks like 66 degrees. Wait a minute. 66.8 degrees. We can round up. What happened to my camera? Yeah. Oh my gosh, my webcam is dead. That's so sad. I had no clue. Okay, we'll get that back up and running. In the meantime, we will just listen to the sound of my voice. All right, this is going to be 6-7. Okay. AZ, you're better than that. No 6-7. I don't know what the big deal is. It's just a number. I don't even know why it's so special. Okay. I mean, it just happened to be 67 degrees. I don't know what to tell you. It just made sense for the design. You can't have me doing the opposite of intuition. That's no better than intuition. All right. So if that's the case, what I'm going to do, I don't even think 6-7 is the current form of brain rot. And also, something weird happened to me yesterday. Something weird happened to me yesterday. I was at Walgreens, and the cashier, after I check out, says to me, he says the most crazy thing. I'm like, why would you say that to some random stranger? He goes, hey, what do you think of the phrase, she 6 on my 7 till I 6? I was like, what? I was like, are we doing brain rot IRL right now? Like, that's crazy. I'm like, you don't know me, dude. I was just like laughing. I was like, huh, good one. I was like, dude, what? What I'm going to do, I'm kind of a silly guy. You know what? Yeah, I'm going to embrace this. I'm kind of a silly guy. So, is this, or should I? Okay, I thought this was going to make more sense. Mm-hmm. I mean, I don't know. I don't know what else to do. I think probably. How do I avoid pinching here? I know I want that feature to be visible. Like if I do this, yeah, let's go with that. Cut this one, cut this one. Okay, I know that these two still belong together, and I want to add that material. It's my life. It's now or never. I don't want to live forever. I just want to live while I'm alive. Okay. That seems promising to me. I'm a little worried about pinching, but maybe it'll be okay. We'll leave that for now. Don't worry about the details. Keep forgetting. So I'm going to do this side and this side, -2, -3. Doesn't matter. We can fix it later. Then we combine these two back. Then we use that to cut, keep the tool. Then we move this 67 degrees this way. And we cut again. It's just an easy number to remember, guys. Okay. The Artemis astronauts were doing 6-7. So as far as I'm concerned, nobody is above it. You also know there's going to be a motor here. And that motor has like a 16-degree radius. This would be 7. That's 16. Okay. Jobs is tough, especially right now. I mean, honestly, the hard truth, at least from like an engineering perspective, is I had jobs from being in college and doing internships and research and that sort of thing. So I guess I can't really speak much to like what it's like if you just have these things as a hobby. And I don't mean to use the word just as if like it's like diminished versus having the almighty bachelor's degree or whatever. I feel like is there a difference between like getting an engineering degree and like having like a maker hobby um, in skill? I feel like yes and no. I feel like there's a difference, but for a lot of jobs, not really. But also maybe there is, but maybe not. Like a lot of people just like to see that you have a degree because it shows that you can think a certain way, I guess, in their eyes. Um, so it'd be tough. I don't know what your education is, but it's just like I don't know what is out there if you just have so and so hobby. I mean, I would hire you. Like if I had the cash flow, I would hire you. I know that this is going to need to be, let's just call it 16 that way. The motor is going to be in here. I don't like the way that this is exposed. So I'm going to rotate it back 6, 7 in high school. So in high school, a couple things. I did a couple things in high school. I interviewed at like a 3D printer company that was in the area. Didn't get that job. That would have been a nice job to have in high school. I also volunteered doing engineering at the Cleveland Clinic, which of course didn't pay anything, but at least was, you know, experience, like a resume builder. Yeah, I mean, other than that, I don't know what there is in terms of like if you want a job in high school that's like doing engineering, you know, like I would hire you for an internship. You know what I mean? I mean, could I? Would you guys work for me? I'm trying to think here. Like, how much money could I spare? It probably couldn't do. I couldn't even do like service industry money, probably. I could probably give you guys like a month-long internship for like maybe $500, which sucks. Like, that's not good employment. You know what I mean? And I'd rather provide good employment. So I don't know. I don't know what you guys think. For free? No, don't work for free. Don't work for free. Yeah, let's think here. You do CAD and 3D printing. I don't know. You want to send me don't so the problem with doing it for free, what I found, because I've had people, you know, work for free in the past, and the issue is you might be sitting there thinking that you're going to be motivated working for free, but all kinds of other stuff is going to come up in your life. You're going to have, you know, financial difficulties here, financial difficulties there, which, you know, every person has, which sucks. But that's always going to take precedent over the work, especially if the work is not paid. You know what I mean? So, like, as an employer, I know that it's important, you know, as a future employer. I don't employ anyone right now. As a future employer, I know that it's important to compensate people in such a way that makes them, you know, comfortable working. You know, it's like everybody needs like a beneficial like return on investment here, you know. Otherwise, I'm not going to get good use out of you, because it needs to, like, if this is just like a month-long internship, basically just needs to like have like you start, you know, working at the beginning of the month, and then we're like, okay, by the end of the month, you are going to have like this and this done, because then I need to carry on after that, you know, without you. So that's basically like how it has to work. So it's tricky, you know. I don't really have the bandwidth to figure out the logistics of that right now. Summer is such a good time for that too. What year are you guys in high school? Tell me. Like, are you looking at colleges yet? Are you applying, or are you early high school, early late high school? 2028 sophomore. You guys are youngsters. You guys are. I don't. I don't like to think about it. You guys are graduating high school 11 years after I did. That's crazy. But that's a good time. So you guys still have time. I mean, I didn't start applying to colleges until like the beginning of June, beginning of senior year, right? That's typically the time when you do. So I think that it could be good, like a good like resume builder, for you guys to have a little internship with me. But I don't know if it's going to be this summer. I think there's too much going on this summer. So if you guys are sophomores, stick around and send me your resumes too, because maybe I'll start the selection process for next summer now. It's totally possible. Um, so yeah, it's totally possible. Like I probably will need to look at a few applicants. I would think, before I just be like, here's an internship, here's an internship. Probably applicants interview. Like I want to do it right. So that's basically what I'm thinking. And then hopefully next summer I'll have like more cash flow as well, so I can make it a little bit more of a thing. You know, yeah. Henry, I think you did. That's true. Yeah, and I'm sorry. You know, I'm sure you can understand. There's just like a million bajillion things going on. I'm also moving at the end of the summer, so that's not great. I mean, I'm excited to move, but it's gonna be a task. So I can't really take on the extra management, I guess, right now. But I would certainly like to see cash flow right now is okay. It's mostly coming from the client projects at the moment. And you can probably see that my YouTube video output has been slightly less. So I was still getting a little bit from YouTube, like a decent chunk, especially compared to how I used to. But it's not what is this? Like 4 million. Let's see what this does. It's not like the primary source. So I'm like definitely better than I was like a year ago. So hopefully next year will be even better. And so you guys can get your internship with me. And I would love to have you. That sounds really cool. But again, compensating people fairly, I think, is important, not just for like you and like morality, but like important for the work to be of good quality. It's about like motivating people properly. And you guys are smart, so like it's not even like I would never do this, but it's not even like taking advantage of someone like you is even an option, and I would never do it. So it's like if I tried to be like, oh, it's all like experience or exposure, like that's how I'm paying you or whatever, that'd just be dumb because I feel like you guys sooner or later could see like right through that. You know, I hate when people do that. Jobs are jobs. Like it doesn't matter how passionate you are about it. Work is work, and you should be paid for it. I'm kind of goofing off here. Yeah, unpaid internships, it's just trash. I mean, so the thing is, there are so many unpaid internships, I feel, and there's so much unfairness in general. I think it's like marketing, basically. And marketing to me is essentially just lies, you know. It's like how people like lie to you to get what they want out of you. You know, if you're marketing a product, you're like you know, you're trying to make the product look as good as possible even though it's not that great. If you're marketing a job opening, you're trying to make the job look like the best thing you could do even if the pay is not that great, you know. And I don't like do marketing. Like I'm not like good at it, you know. So it doesn't matter how important I think the work here is. I think it's super important. It's like not up to me how important other people think it is, you know. It's not up to me how important other people think it is. I think it's important. So I should be willing to shell out the cash to get it done. That's sort of the dealio. Yeah, that's a good point, Billy. I think like ultimately it comes down to the fact that like right now I'm not a manager, you know. I'm all these things for my company, like a shit ton of things, right? Social media, engineer, like web designer, like salesman, like all this stuff um, for my company. But I'm not a manager yet, right? That's another thing to add. Like that's another responsibility, and I'm not sure that that would be like a good idea at the moment for me to have that extra role. But eventually, yeah, it will have to happen. You know, I mean, especially like if it's like an internship, then you kind of you have to be a manager. Like, no offense, like if I'm managing two high school students, I can't just have them, you know, do like you know whatever they want because like they just don't they don't have the experience. That's what the internship is for. So like I need to manage them. It's not like, oh, this is we're working together, we're collaborating on this, you know, like I would with like a fellow grad student, you know. It's like, no, like I need to keep you guys on track and mentor you and help you have the right like trajectory for this project. So that's definitely like, you know, it would be an extra load in some sense, but in another sense it wouldn't be because I'd have more manpower. Guess we just have to see. The other thing is that if it's an unpaid internship, then you can't really be like beggars can't be choosers, right? You can't really be selective with the process. Like, I'd rather get the best candidate for the job um, than be like, oh, whoever wants to work for free, you know, because it's just not going to be worth it. Anyway, what am I doing, man? I know what I'm doing. I feel really silly about this part, but this is where I'm at now. This gap here. I don't know if that's going to come back to bite me. I got this big gap. That's there. What is advocating for the sophomores? I remember what it's like being a sophomore. I started doing this when I was a sophomore in high school, you know? So that's like, it's a pretty good time, you know, to start dreaming about the future and never stop. Adding some random chamfers here. All right. Got him. We're back. Well, the Gleep Glorp camera is back. We got the Gleep Glorp quality back. Hooray! All right. So let me check this again. This rotates 67 degrees. Just like that. I quite like that. It's got a weird, weird shape. I know I shouldn't worry about the details right now, but sometimes I can't help myself. It's a problem. Yeah, that still fits. Perfect. Just how I wanted it. Okay. It's also like the manager role is not really something I'm unfamiliar with because in grad school you manage undergrads who are working on your project. Um, and I remember that well. I had some really, really good ones. This poster on the wall behind me, shout out Madhavan, my prize undergrad, now doing a master's at Carnegie Mellon. Um, he was as committed to that project as I was, if not more. Um, and that was great help. And he knew a lot about stuff that I didn't know a lot about, but I still had the overarching sort of vision for the project and could delegate the tasks. That's sort of the best manager relationship, I feel, is that when everybody has different skill sets, so it's kind of like a team, um, but there's still like if you're the manager, like if I'm the manager, I get to guide sort of the overarching goal of the project. But then I also don't want to be completely have my hands not get dirty with the project because I like that. Um, so what's next? We've got the hinge. It's not exactly like modeled yet, but we have it. But we have it. And then we need the sliding part. Which again, so now we get to the part where we split this body. And combine these two. And then this is the adjustment. That's the adjustment right there. So big wrist, little wrist, big wrist, little wrist, big wrist, little wrist. And then of course, we're going to need to change the shape of this a little bit so that every version of this shape is comfortable. Which one of these pieces is the pressure vessel? Good question. Yeah, really good question. So it's going to be this one, right? Because it's the one without the hinge, and it's the one with the nozzle, which will be like right here. So that's going to be the pressure vessel. But then, yeah, it's like, I do want to store like a little bit more, So I'm almost wondering, I mean, like, there's not really something we can do. I think it's got to be right around there. But where did I put the... I don't want to have to go through my 500 sketches again. Oh my god. So the hinge won't be built into the pressure vessel. Yeah, that's true. That is what I was gonna do. but the hinge has to slide upside down, up and down for this to be adjustable. So I realize now that that's not really possible with the way that I'm doing this. But yeah, you're right. We could store so much more fluid if it was bigger. There's some competing ideas here for sure, and I might need to take some time to deal with them, especially since I should eat some food. Can you pause a stream? Is that possible? I would love to pause it and then like get back to it like in a few hours, you know? That would be chill. But I could just stop it and start another one later. So what was I doing? I was looking for my thingamajig. My no. There. Sketch 480, which I'm going to rename Hex Inlet, if I can find it better. So yeah, so that's squarely like in this part. But it could fit over here. And in fact, maybe it should. Good Lord, what is happening? You good, bro? I might not be able to build the hinge into the pressure vessel, but I probably could build the... I'm going to make this a body now so I can move it easier later. Probably 16 millimeters, something like that. New body. But then, if that's sliding, that's not really possible. So I'm going to move it back. It's like this seems to be like a healthy, just like a healthy spot for it. You know? Thanks for asking ChatGPT for me. That's very kind of you. All right. I think I'm going to have to start a new one later, which is fine. We're set up for it. So consider this part 1 of today's stream. And we've still got at least, a couple hours left on this print anyway, so we won't be able to try anything out. But yeah, we've got a good start. We've got a hinge. We don't really have everything designed, but we have like the location of the hinge. We have the location of the sliding. We have like the shape of the whole thing. We have space for both motors. We have space for the trigger slot. It's looking pretty good. Let's look real quick. Should we hope or cope about this thing. This circuit board. Should we hope or cope? Because I'm not yet at the point where I want to try to find place for this, but yeah. So this gives us space for the battery too, which is really nice. Okay, that will fit in there, and then we want to rotate it about. Wait a minute. No. We want to rotate it. Well, we want to move it from here to here first. Then, wait, what's happening here? What's going on? What are we doing here? Okay, maybe I just have to free move it. I think there's going to be a way. Oh, I remember how I did this. Okay. Yeah, so it's not exactly like a perfect fit, but that's in the annulus, the ring. Then I can maybe rotate it around the annulus. So here would be within the current shape of that door, which will have it stick out a little bit into where I don't want it to be. However, I think that we can push it a little bit downward. Let's get this in here. Ooh. And then we can, oh, wait. Yeah, because we should have this towards the back so that the battery can be in the front. And the LED can shine out. The LED is up here. So I'm thinking there's nothing wrong with like having the USB port stick out, you know, to like here or something like that. And then like this is proving to be a kind of strange shape. Okay, so like this, and then there will be just extra space, you know, for the USB port to kind of sit in the other part. It's kind of what I'm thinking. Once you start part 2, will you be building the new enclosure that is currently printing? Probably not, because there's still more parts to print. Yeah, probably not. But we're getting close. I'll like certainly start it, but it's just like a lot of big parts I need to print. And then I also still haven't designed all of it yet either. Okay, so thank you guys for watching. This has been part 1, and maybe later, hopefully later, probably later, we'll get to part 2, and it's going to be great. Okay, thank you guys so much for coming. I appreciate everybody who has tuned into this stream. We've had some great conversations. We've talked a lot about engineering and employment and all sorts of things. So thanks so much, and I'll see you guys later. Amazing out. Yikes. Bye.